Hey, I'm Alex Frankor, head of product over here at Xata. In this demo, our lead engineer for pgroll, Andrew Ferris, walks us through multi-version schema migrations in Xata. This is a brand new way to make schema changes in production, allowing both new and old schemas to be accessible to your application at the same time. pgroll is an open source tool we built that enables zero downtime, reversible schema migrations for Postgres databases. With our latest release, we've integrated pgroll into Xata to provide the same experience through multi-version schema migrations. In the following demo, Andrew dives into exactly what a multi-version schema migration is and how it simplifies database changes in production environments. He walks us through the developer and user experience in Xata, highlighting the different states in a migration lifecycle, the history, and how to write migrations. Ultimately completing the migration and showing how simple schema migrations can be with this new approach to an old, painful problem. Take it away, Andrew.
Hi, I'm going to show you how to use multi-version schema migrations to make a schema change and have both versions of your database before and after available to client applications. I have a simple users table here with a straightforward schema and a few rows of example data. I want to add a not null constraint to the email field. Notice that the email field already contains a null value. How can I do this using multi-version schema migrations? I start by heading to the migration editor. Migrations in Xata are defined using pgroll. pgroll is our open source Postgres schema migration tool. pgroll migrations are written as JSON documents that declaratively describe the change we want to make to the schema. Here we're making an alter column change to the users table, and we're going to set the email column to nullable false. Alongside the schema change, we also have to define a couple of data migrations that say how we're going to move the data from the old version of the column that doesn't have the not null constraint to the new version that does. In that case, we're just going to copy the value directly from the old column to the new, unless the value is null, in which case we're going to replace it with this placeholder value. In the other direction, when we want to move data from the new version of the column that does have the not null constraint to the old version of the column that doesn't, we can do that as a straightforward data copy without any modifications. I can start this migration and head back to the users table. The email field is now in a multi-version state. We have two versions of the email column, one with the not null constraint and one without. We can see that the data migration we defined in our migration file has taken effect. The null value that's in the old version of the column has been rewritten to a placeholder value in the new version. What does this multi-version table look like, though, to client applications, and how do client applications work with multiple schema? We can start a couple of Postgres sessions and see how each session can work with a different version of the schema. Here on the right, I want to work with the new version of the schema. In order to work with the new schema, I need to set the Postgres search path. And to know what to set the Postgres search path to, I need to know what this version of the schema is called. To find the name of this version of the schema, I can go to the schema history view. The schema history view is a complete list of all the schema changes that have been made on this branch since the beginning. Each version of the schema has a name, and I want to find the latest version of the schema, grab its name, and set the Postgres search path to that name. Once I've set the search path to the new version of the schema, I can select the data in the table. And I can see that I am working with the new version of the schema because the email field has this placeholder value that replaces the null that's in the old schema. Here on the left, I want to work with the old version of the schema. And again, I need to set the Postgres search path. I can go back to the schema history, find the previous version of the schema, grab its name, and set the search path. Now I can select from the users table again, and I can see that I am working with the old version of the schema because the email field contains a null value. In the old version of the schema, I can insert null values into the email field. The old version of our database schema does not have a not null constraint on the email field, so that insert is valid. If I try to insert a null in the new version of the database schema, though, I get a null constraint violation because I'm here working on the right with the new version of the schema, and the new version has a not null constraint on the email field. If I select data in the new version of the schema, though, I can see that the null value that I wrote into the table using the old version of the schema has been replaced using the data migration from our migration file and has been replaced with the placeholder value. If I insert a not null value into the email field, this works just fine in the new version of the schema, and the change that I made through the new schema is reflected in the old. So we have two different Postgres sessions connected to the same database, but using different versions of the database schema. And the schema multi-version migration is keeping both versions of the data in sync. Eventually, I'll be finished with the old version of the schema, and I won't need to keep it around anymore. Perhaps the application rollout is complete, and all of the applications that depend on the old version of the schema have been shut down, and the rollout of the new version is completed. At that point, I can head back to the UI and complete the migration. Once the migration completes, the users table is back in a single version state. I have just one version of the email field with a not null constraint. Multi-version schema migrations allow you to keep both versions of your schema and data available during a migration. This greatly simplifies application deployments and reduces the difficulty of keeping your database schema and deployed applications in sync.